So today we will be talking about how ellipse word problems. So let us get started. We have this example here. A company is planning to build a racetrack for testing autonomous vehicles. The racetrack is designed in the shape of an ellipse. The company wants the racetrack to have a major axis of 1 km and a minor axis of 600 meters. The starting point for the vehicles is located at one of the vertices of the ellipse, while the finish line is positioned at one of the co-vertices. So first, we're going to determine the equation of the ellipse representing the racetrack, and then the vehicles on the racetrack travel at an average speed of 50 meters per second. We want to calculate the time it takes for a vehicle to complete one lap around the racetrack. So first, we're going to find the equation of the ellipse. So the equation of an ellipse is centered at the origin, and it's given by this equation. So we have x squared, oops, that looks funky, x squared over a squared plus a y squared over b squared is equal to 1. And so this is a general form of the equation of ellipse. We know a is the length of the semi-major axis, and b is the length of the semi-minor axis. So given that the major axis 2a equals 1 km, 2a equals 1 kilometer, and the minor axis 2b is equal to 600 meters, we have a equals 1/2 km, which is 500 meters. And we know that b is equal to 600 over 2 meters, which is 300 meters. And so if we plug this information into this ellipse equation, we see that x squared over 500 squared plus y squared over 300 squared is equal to 1. So this is the equation of the ellipse representing the racetrack. This is your answer to number 1 right here. And so now we want to calculate the time for one lap. We know that the perimeter of the racetrack is approximately 2 pi times the semi-major axis. So the distance a vehicle needs to travel to complete one lap is approximately 2 pi times 500 meters. So we want to use the average speed of the vehicles, and we can calculate the time it takes for one lap. So I'm going to scroll down a little bit here. We know that the time for one lap is the distance of one lap divided by the average speed. And so we know that the time for one lap here, I'm not going to rewrite it, but the distance of one lap is 2 pi times 500 meters. And the average speed is 50. And then we're just solving it. So this is 1,000 pi divided by 50, which is 20 pi seconds. And actually, I'm going to go ahead and write seconds for all of these so we don't forget. Cool. So we know that the equation of the racetrack's ellipse, I'm going to rewrite the answers here. So question number 1's answer is x squared over 500 squared plus a y squared over 300 squared is equal to 1. That's the equation of the racetrack's ellipse. And then for question number 2, it takes approximately 20 pi seconds to do one full lap.